Good. Okay, let's get started. Now, so long division is something you would have learned about in elementary school. You know, the usual, like, whatever, 12 into 100, and you go through this process. We can do the same thing for algebra as well. You can take something like a cubic and divide it by something else. So I think what I'll do, I'm also aware that the process might be a little bit different in different countries. So I'm just going to show you the way we usually do it here, but if you've seen a slightly different way, that's fine too. I'm thinking South American systems do it a little bit differently, I know. Anyone from a South American system? No? Okay, so maybe everybody has seen it done this way before. So how do we long divide? Let's take an example like, let's not make it too difficult. X minus 1 divided into 56x cubed minus 25x squared minus 28x minus 3. Okay, so I'd like you all to write this down carefully. We'll do a couple of examples of the process here. What you do first is you look at the first term here and the first term here, and you decide, what do I multiply this by to make it become this? 56x squared. That's the first step. Then what you do is you carry out the multiplication. So you take this and you multiply it by both. So obviously 56x squared by x gives us what we wanted, which is 56x cubed. And then 56x squared times minus 1 gives me minus 56x squared. That's the second step done. Now the third step is you subtract. Now be very careful. They cancel, as they should. And here we have minus 25 minus 56, which I think is 31. That's the third step. And now the fourth step is these remaining pieces we carry down. And that's one cycle complete. Then we start again. So once again now, we look at the first piece here and the first piece here, and we say, okay, this time I will need 31x. And then you carry out the multiplication. So 31x by x is 31x squared. 31x by minus 1 is minus 31x. That's the second step done. Then you carry out the subtraction. Yeah? So what's that? 3, isn't it? 3x, and then you carry this down, minus 3. And one more cycle left. X and the 3x, what will we need? We'll need 3. Carry out the multiplication. We get 3x minus 3. Carry out the subtraction. We get 0. Nothing left to carry down, so we're finished. So we can say 56x cubed minus 25x squared minus 28x minus 3 divided by x minus 1 equals 56x squared plus 31x plus 3 with remainder equal to, in this case, 0. There's no remainder here. It's okay if you get a remainder. It's fine. Well, at least for this one, it's fine. Okay, carefully copy this into your notebook. We'll do another example. got that? Can we scroll down?
No.
No. Does anybody know what the answer on the top is called? The 56x squared plus 31x plus 3. It is a polynomial, it's a quadratic, but in the long division, what's it called? Quotient, yeah, quotient here. The Q, quotient, yeah? Isn't it? Yeah. Also, because there's no remainder, the x minus 1 is given a special name. I wonder if anyone knows. It's called a factor, yeah. If there's no remainder, we can call the divider a factor. Factor, yeah? Right, let's look at another example now. Okay. I'm curious, has anybody seen this done a different way in their school? Everybody has seen it this way? Yeah? Yeah? Or never seen it either? Yeah. Okie dokie. Continue? Yeah. So let's have a look at another example. Let's make it a little bit different. This time what I'll do is I'll take a quadratic and I'll divide it into a cubic. Now, in fact, this is, you could say, easier because there's less cycles. How many cycles did the last one need? It needed 3 in total. Whereas I think this one here will only need 2. What's the first multiplication term? It's x. Let's carry out the multiplication. X cubed plus 3x squared plus, finally, 2x. Yeah? Subtraction next. Cancel. 3x squared, isn't it? Plus 9x, and then carry that fella down. 6. And only one more cycle left. 3 is the last one. 3x squared plus 9x plus 6. Subtraction 0. So it's actually shorter to divide a cubic by a quadratic. Only 2 cycles needed. Okay, write this one down. We'll go to a different type. Okay. Yes? Continue? Yeah? Okay, next one now. So this one is as follows. Is x minus 1 a factor of 9x cubed minus 14x squared plus 13x minus 8? So no prizes here. How do we check? What's one way we can check if it's a factor? if the remainder is 0. Okay, now I'll give you this one to practice and then I'll give you the answer. I want you to divide and see what remainder you get. So what are we thinking? Is it looking like it's a factor or not? The remainder is 0? Oh great, I'm hearing two different answers. That's wonderful. I think it's looking like a factor. Yeah? Let's check. So what's first here? 9x squared, yeah? 9x cubed minus 9x squared minus 5x squared and carry down. Okay, so the next one you should have is minus 5x, is it? Minus 5x squared plus 5x, leaving me with 8x minus 8. Plus 8, yes, thank you. 8x minus 8, 0. So that means it is a factor. Yeah? Okay, if you got this wrong, just fix it up, please. Let's look at another one now. Okay, we got that? Yeah? Let's look at another one now. So, let's say I have a question like this one. Simplify 25x cubed plus 45x squared minus 81x plus 27 over x plus 3. Now if you think about this, it's a long division again, because having a over b is the same thing as having a divided by b, right? So really I'm asking you here to do a long division. However, you absolutely need there to be no remainder in this example. Let me show you again on the side why. So suppose I had a question like 100 over 5. This is equal to 20, right? That's fine, because when you do your 5 into 100, it goes 20 times and the remainder is 0. But if you had something like 101 over 5, when you do the long division, 5 into 101, how many times? 20, and the remainder is 1. So it is wrong to say this is equal to 20. Now, we know how to deal with this in maths. You know, you would say it's equal to 20 point something. And in semester 2, we will learn what to do if we do get a remainder. But for semester 1, for this type of problem, we really need there to be no remainder, okay, for it to work. But don't worry, if there is a remainder, we'll learn what to do in semester 2. But for now, no remainder. So this is another long division. Let's see how quickly you can do it. So as quick as you can, let's see what you can get here. Off you go. Question? Yeah, what's up? No, just stretching. You got it done? Yeah. Okay, let's have a look. First one, 25x squared, isn't it? 25x cubed plus 75x squared. You subtract, what's that, 30? No, minus 30x squared minus 81x plus 27. So the next one has to be minus 30x, which is minus 30x squared minus 90x. So what's that? 9x plus 27. So that's 9, and that finishes it, doesn't it? Yeah. 9x plus 27 and done. So the answer is 25x squared minus 30x plus 9 is what this simplifies to. Okay, 2 more examples. So I hope you got that. If you need to fix any mistakes, can you do that? And we'll have a look at the next one now. I'm going to scroll down. Just fix any little mistakes that you might have made. Okay, scrolling down. Right, next one is factorize 6x cubed plus 9x squared plus x plus 14. And I give you a little hint. X plus 2 is a factor. Okay, so let's have a look at this one now. My question is, I want you to factorize this cubic. Now, we learned how to factorize a quadratic. Remember, we did that last week or something. Cubics are a little bit trickier to factorize. It's really, really helpful if you can have one of the factors to begin with. So we know that one of the factors here is already going to be x plus 2. Okay? But there's going to be other factors here. How many factors here?
3.
Now, just in this extra piece. Maybe 2 or maybe 1. If it is 2, what will it look like? It will be 2, what type go in here? Yeah, but what's it called? Linear. So you could have linear, linear, and a linear. And if you multiply them, you get your cubic. Or, what's the other possibility? You could have, yeah? Quadratic, yeah. You could have a quadratic here. Quadratic multiplies a linear, makes a cubic. Anyways, we don't know exactly what we have here. We have something, that's for sure. And we want to calculate what the missing factors are, right? So watch this little trick. You can divide this underneath Now, have we seen this problem before? Yeah, we just did it. So whatever answer you get here, that will be the missing factors. So we have one factor already, and when we long divide, we can get what's the missing factors. Okay, so again, another practice example for you. Let's see how quickly you can divide. Go ahead. See how quick you can do this. X plus 2 divided into 6x cubed plus 9x squared plus x plus 14. Got it? Yeah? Yeah? So let's see, what's the first one here? It's 6x squared, isn't it? So that's 6x cubed plus 12x squared. That's minus 3x squared plus x plus 14. Next is minus 3x, so that's minus 3x squared minus 6x. Is that right? So you're finished with 7x plus 14. So the last one is 7 and then remainder 0. It's possible that this guy can be factorized. Now, if it can't be factorized, it means the answer is this. These two multiply to make the cubic. But maybe it can be factorized. One way to check is the discriminant. Is it positive, negative, or 0? It looks negative to me, because it'll be 9 minus much more than 9. So I don't think this can't be factorized, right? No factors. No roots. So the answer is this linear multiplied this quadratic. Now, if you don't believe me, if you wanted to, you could multiply these out, and you'll discover that you do get this cubic. So this is the answer here. In the exam, now this is important, in the exam, sometimes students make the mistake of forgetting to give this answer, which is really sad, because they were given this answer in the question. You know, the question would be, what are all the factors? Or, factorize fully. And sometimes the students say, this is the answer, when really they mean this is the answer. They just forgot that they got this answer for free. It was given in the question. It said at the start, hint x plus 2 is a factor. You already have one of the answers, But please, in the exam, make sure you give all the factors, including the one that maybe you were given in the question. Yeah? It's a stupid reason to lose a mark, right? Okay, one more example. This one's a little bit tricky. Let's see if you can figure it out. Well, I'll just give you a minute to write that down in case you need to. It's going to be simplify. Can I scroll down? Okay, simplify this. And I should put in a note here, using only long division. Because I know there's another way to do this if you know the formula. Yeah, but no. Using long division, simplify this. Now you'll get the same answer. But see what happens. Give it a try. Barack, yeah, help. Amy, there you go. Alex? Oh, there you are. Diana? Mohammed Omar? Oh, there you are. Hussein? He's sick, okay. Hussein. Got it? Got it? Right. Let's have a look now. This one's a bit tricky. Guys, look up. Look up. Look up. X minus y divided into x cubed minus y cubed. Okay, it starts off okay, right? So it's the first one. X squared. And this will give us x cubed minus x squared y. Then we subtract. So, these two, they don't really combine in a convenient way, do they? They can't be added together. So you end up with just minus y cubed plus x squared y. You can't, it's not like 5x and 6x. You can't just stick them together. They remain separate like this. Yeah? Oh, because I'm subtracting the two lines. Yes? No? Minus y cubed minus x squared y is plus. Now, you'll make your life a lot easier if you write the answer instead like this. X squared y minus y cubed. After all, it's no different. A plus b and b plus a is the same thing. I've just swapped them. There's no difference. Okay? But doing it this way makes it very clear what the next multiplication should be. It should be xy. If I multiply it, I get x squared y minus x y squared, isn't it? And I subtract, and what am I left with again? I'm left with xy squared minus y cubed when I subtract. What is the last multiplication here? It is plus y squared. So that would be xy squared minus y cubed, finishing me with a 0 here at the end. Now that, obviously the hardest example this morning, it's the last example, okay? You probably won't get this in the exam. I mean, I've never seen a question as difficult as this, but just in case you're prepared, this is what I can consider the most difficult long division question, because you have to be very careful with x's and y's, yeah? Yeah. I did say I know, that's why I said at the start using only long division. There's always an easier way in maths. Always. But I wanted you to do it this way to practice long division. Anyways, I could easily change this question so that you don't have a formula. I could have said, for example, x4 minus 1 over, okay, maybe not quite that. I could have said x5 minus y5 over x minus y. So now you can't use a formula. And I know that this will divide. I know that this will have no remainder. I'm confident that x minus y does divide into x power 5 minus y power 5. It's just I don't know how many times it does. But I do know what type of answer I get. What will be the first piece? It'll probably start with an x power 4. And then the next piece will probably be an x cubed with a y and so on and so on. Anyways, the point is, this is the most difficult type of long division question I could think of. In the exam, they tend to do cubic divided by linear. And sometimes, I mean, this would be 90% of the problems. And 10% of the time, it would be cubic divided by quadratic. So, you know, I think everybody was quite comfortable doing this and doing this. Yeah. So this is okay. How are we doing? Okay, so what I'll do is for about, what's that, about 6 or 7 minutes, practice some of these. Now, I'm going to give you a good few because the next, long division is a safe question for the exam. There'll probably be a long division on it. So let me see. I'd like you to try 1a, that's a linear, 1l, 2, ooh, yeah, this one's a bit tricky, 2b, 3a, 4b, 5i. Right, there's 6 questions there. You can get a start on them now.